Hey everyone, this is a quick video on what we covered in Friday. For those of you that weren't here, you may very well see a problem like this on Tuesday's quiz. These are two separate problems, so let's just attack them one at a time. Now, up until this point, all we've been able to do with our expressions is to simplify, and we've been simplifying using them all those exponent rules. We just leave them as variables because we didn't know what the value of those variables are. So all we could do is simplify them down. But what is different about this type of problem is we know the value of X and the value of Y. So we can actually come up with a number that represents this expression using these two values. But before we do that, we need to simplify this expression. Now, as a side note, if you wanted to, you could go ahead and plug these numbers into this expression right away and then evaluate using the exponent rules. I would recommend that you simplify this down first and then plug the numbers in. But either way works, and that's what's great about math is there's different ways to do the same problem. So let's forget the values for a moment and let's just simplify this expression using our exponent rules. So whenever I see an exponent and some parentheses, I know that I want to distribute that exponent to what's inside the parentheses. So that's going to look like 2 raised to the 2 power is just 2 to the second. X raised to the second power raised to the second power. All I need to do is multiply. 2 times 2 is 4. So there's my new exponent for X. X to the second, remember this is like a 1. So is this Y while we're at it. So this is 1 times 2 is X to the second power. And Y also becomes to the second power because 1 times 2 is 2. Okay, so we've raised an exponent to an exponent. Let's see if we can do any multiplying or dividing with the same base. I'm seeing here that I have X's in my numerator and the denominator as the same base. So I can go ahead, let's make sure we're lined up here. I can go ahead and subtract those exponents. Also in the same step, we know that 2 raised to the 2 power is 4. And then my X, again, is going to turn into 4 minus 2. 4 minus 2, there's my exponent. And then Y, there's nothing we can do with the Y, so it's just going to stay down there. Let's subtract our exponents up here and simplify. So this becomes 4x squared all over y squared. Now, written above, so what we've done, we simplified from this to this. That looks a lot nicer. And we also know that x equals 2 and y equals 3. So all I'm going to do is plug those values into my variable and evaluate. So this is going to become 4. Instead of x, I'm putting 2, and that's going to be to the second power. And then instead of y, I'm plugging in 3. And that's also to the second power. Simplified. I'm going to keep that 4 there for a second. 2 squared is also 4. And this 3 squared is 9. Final step, 4 times 4 is 16 over 9. For these type of problems, we can just leave them as fractions. It's fine if they're unreduced. It's fine if they're improper. That's not what we're focused on this unit. So you can just leave it as those two numbers in the numerator and the denominator. Okay, one more. I'm asked to find the area. Let's assume that's a right triangle. Okay. We're not going to be able to find the exact number because we don't know what A and B are, but we can come up with an expression that represents the area of this triangle. So the first thing I need to think about is, hey, what is the formula for the area of a triangle? And that is base times height all over 2. Luckily for us, we know what the base and height are. We don't know exactly what they are, but that we know what variables represent them, the expression that represents them. So all I'm going to do is plug in these two expressions for my base, which is going to be this one, and my height, which is going to be this one. So this is going to turn into 2a b to the fourth. No, what am I doing? 2a times b to the fourth times the height 7a squared times b. And that's all over 2. I'm not going to worry about this 2 because I can clean this up. So let's simplify kind of by combining like terms. Remember, this is one big multiplication problem. All these terms are being multiplied by itself. So I just need to find some like terms. And my like terms in this problem are going to be the whole numbers, 2 and 7. The variables with the same base, which is going to be a. And lastly, I've got my b's to take care of, okay, represented by that blue arrow. So let's do that. And I can just do it right over here. So 2 times 7, that's 14. A's in the green, well, I got the same base. All I need to do is add the exponent. This one has an exponent of 1. This one has an exponent of 2. 1 plus 2 is 3. So there's my new exponent, a to the third. Same thing over here with my b's. They're the same base, so I add the exponents. 4 plus 1, that's 5. B to the fifth, all over 2. I can take this down one more by just dividing the 14 and the 2, the whole number there. So this becomes 7a to the third, b to the fifth. And that's it. Again, we're not coming up with an exact area of that triangle, but that is the expression that represents the area of this triangle given its dimensions. Thanks for watching.